Oxidation of side chain benzene. Reactants of benzene, an alkyl group attached to benzene which contains hydrogen atom. Conditions are strong oxidizing agents such as acidified KMnO4, potassium permanganate, or Na2Cr2O7 or K2Cr2O7. These three are examples of oxidizing agent, and it must be heat. So oxidation only happens at the side chain of the benzene ring, because we know that this benzene ring is very stable. It cannot undergo oxidation. Benzene ring is very stable, so it only occurs at the side chain. So whichever carbon of the side chain of the benzene which has benzylic hydrogen, it has hydrogen atom, it will undergo the oxidation. So you look at the side chain of benzene ring, the carbon that has hydrogen atom, that will undergo oxidation. For example, here toluene reacts with oxidizing agent K2Cr2O7 and acidified. Okay, it must be acidified. So H3O plus means water, acidic, acidified water, and heat. So only this carbon will be oxidized. So it will become carboxylic acid. And then propylbenzene. So here benzene ring is very stable, so it will not undergo oxidation, but the side chain, the carbon that has hydrogen. So this carbon that is attached to the benzene ring, only this carbon will undergo oxidation. Ignore other carbons, so it will become COOH. So just ignore the other carbon over here, and the side products are water and carbon dioxide. Oxidizing agent, acidic, heat. And here, if look at here, the side chain carbon, this carbon has no hydrogen at all, but other carbon has hydrogen, but the other carbon does not attach to the benzene ring, so it will not undergo oxidation. The carbon that is attached to the benzene ring and that carbon which has hydrogen, that carbon will only undergo oxidation. Other carbon, they are not attached to benzene ring, so they will not undergo oxidation. Since this carbon has no benzylic hydrogen, no reaction happen because no hydrogen for the carbon attached to the benzene ring. No reaction over here, no oxidation will happen. Alkyl group, regardless their chain length, are converted to COOH. As I've mentioned before, this carbon attached to the carbon of the benzene ring, it will become COOH, it will undergo oxidation, and this carbon, it has hydrogen, it will become COOH. Other carbon that will not attach to the benzene ring, just ignore them, just make COOH. How many carbon over here? Just ignore them. So it will become COOH and COOH. Only focus on the carbon that is attached to the benzene ring. Compounds without benzylic hydrogen are inert to oxidation. For example, this carbon will undergo oxidation, it will become COOH, but this carbon that is attached to benzene ring has no hydrogen at all, so no reaction will happen at this carbon. For this hydrogen is attached to the carbon of this carbon is not attached to the benzene ring, so oxidation won't happen here. Oxidation will only happen at the carbon that is attached to the benzene ring, and that carbon has hydrogen. Since this carbon has no hydrogen, no oxidation happen on the right side, only on the left side oxidation will happen. Here, no change.